So right now we're looking at our sample problem, and we know that Joe wants to make this drone. He wants to create these arms that move from one configuration to the next. And we read in the problem that one position will be at the slightly elevated 15 degrees above horizontal in flight condition, and the other will be in a vertical position. And we see a bit of that in the configuration here, where we have in our deployed position or our flight condition, here's our arm, and here we have our vertical condition. And we can also see how this point here, our C1, correlates to C2 in the second. Likewise, we have D1 correlate back to D2 over in this configuration. As we look over here, we can know the distances from C1 to C2 as 15 centimeters in the X and 10 in the Y. We also know that Joe wants to build these arms to have, or the mechanism to deploy these arms with these given conditions for links 2, 3, and 4 in this 4-bar device. Now we can quickly synthesize this type of mechanism here in SolidWorks. And what we're going to do here is we're going to create a new sketch, or a new part. We'll open that up. And what we'll want to do first is create a sketch. It doesn't really matter what plane. We'll select the front plane. Once we're good to go, there we go. Actually, let's back out of here real quick. We're going to change the units on this to centimeters, grams, and seconds. So that's what we're working in. So now we'll create a sketch on our front plane. And what we'll do first is create those two positions. So we've got our vertical, and we've got our flight condition. This is going to represent the two positions. We're going to set those equal. This is going to represent the two positions that our arm has to move through. Now, because we know that this arm has to equal a certain length, we'll come in here and we'll define this length. I think it was 25 centimeters. R3 is our coupler. So we're going to come in here and we'll set this to 25 centimeters in length. Also, if we look in the problem, we know that the distance in X, the change in X for this point is 15 centimeters. We also know that the change in Y is 10. And so that's going to constrain all of our positions here, that our device now has to move from this configuration up to this configuration. And to help us see that and make sure those are in the right spot, also we need to make sure our orientation is correct. And we know it's moving from vertical all the way up till it's 15% above horizontal. So to give us 90 degrees plus the extra 15 to get us up puts us at 105, just like that. Now that we can see those positions and where they're at, what we'll do then is we'll close out this sketch. Actually, let's grab something real quick. We're going to grab this dimension here with the come here. And this is named D4 at sketch 2. We're actually just going to copy this real quick, and that'll make a little more sense here in a moment. Now that we have that, we'll come in here and we'll create a new sketch on top of this one, and we'll do it on the front plane. You want to be careful not to do it in the same sketch. We're going to go right on top of that, and we're going to create excuse me. What we need to do now is understand what's going to move us from this configuration to this. To do that, we're going to create perpendicular bisectors to these lines I'm about to draw. So we're going to draw a vector or a line from our first configuration, the C1 up to C2. And it's kind of nice to create that just as a construction line, just to keep things straight. And we'll create another one for point D from here to here. And this one also will create as a construction line. Now what we'll do now is we want to create what are called perpendicular bisectors from each of these lines. What we'll do then is we'll come here and find the bisector point, and we're going to draw a line that is, it doesn't really matter, we'll draw it this way for now, that is perpendicular to it. We'll do the same for our other bisector, and we'll draw a line. Now what we're really looking for is what's called the pole. And the pole is the location where these perpendicular bisectors intersect. And you can see here these lines are moving away from each other in this direction. What I can do is grab both of these points and merge them, and that will give me the location of my pole. This point right here is pretty much where all the magic happens in this graphical approach. So now that we have our pole, we can say happy day. We're going to leave that be. We're going to close that sketch, and now we have a sketch with our positions and we have a sketch with our poles. And all of this, if you notice, has been parametric. We haven't defined any lengths except for what's in the first sketch. Now we'll create a new sketch on top of this, again on the front plane. Now this sketch is where we're going to create what we call our fixed angles. What we'll do is we're just going to create a couple lines. We'll create a line here, and this line we're going to take its midpoint and cause it to intersect our pole. Make those coincident. We'll draw another line, do the same thing, and this one, what happened? We'll also make this point coincident at the pole. What the? Alright. Today's not my day. Also coincident. Now these two lines need to be separated by a given angle. Sometimes, actually, real quick, it's kind of nice to have these just set it as equal lengths, and you can kind of see how they'll move relative to each other. We can move these around as we go. But these lines need to be at a certain angle apart from one another. And this angle, yeah, I always want to do that. This angle, we're going to define this, is we're going to say this is equal to what we copied earlier, that dimension, the dimension of our rotation. It's from here, our first position, rotating up to our second. Now we want to remember what direction we're referring to this as. And as we're looking at this in the counterclockwise direction, that's going to matter. Now we can say that angle, and we're going to divide that by 2. And we're going to constrain that to be just like that. So now we have this set of angles that we can rotate and move. And this is what's going to help us understand where we can draw link R2, or our link from ground up to point C. Now we're going to do the same thing. We have another set of angles. This is pretty much a repeat. We're going to draw. We're going to let this intersect our pole again. Coincident. Say thank you very much. One more. This one also coincident. Here. Thank you very much. We'll set these two equal to each other. And something we'll also do is we'll make these construction lines. And what that'll do for us is that'll help us keep straight what set of lines we're working with. Now the distance, the angle between these two, is also going to be half of that rotation angle from positions 1 and 2. So we'll set that again equal to, and in this case we can probably just set it equal to that angle. They're the same. And we'll say OK. So now we have a second set of angles that will rotate and move, and this is what's going to provide us with R4. Yeah, R4. And so that's looking pretty good. So we can say OK there. Now, as we talked about earlier, we are interested in the rotation from keeping straight, this is clockwise from our first position to our second. That's how we've defined these angles. So, likewise, we want to keep straight this line and this line separated by this. Always think of this as being in the same direction as you measured this angle. So as we go clockwise about this direction, this line is going to be the one that connects to our coupler. So if we can, we'll move this around like so. This is going to be very basic. We'll talk more complexities later, but we're going to let this line and this point be coincident, just like that. And that's going to set this to be where it is. Actually, that's D2. I guess it doesn't really matter. Just keeping straight which one's which. Likewise, we're going to do this line here. We're going to set to be coincident with this point. We'll say OK. Now, this is where some of the magic kind of comes in. We're going to come up here. We're going to hide these dimensions so we have a better view of what's going on. Hide show. We're going to close out those sketch dimensions for a moment. Now, what we're going to do is we're going to draw a line. Yep, we're going to draw a line that goes from this line to this line. Now, if you look at this point is, well, this line here is R2, where it's going to be what goes from ground over to where we connect to our link. And so you can see here's our coupler. We're going to connect this point right there. Right there. Let's say OK. And you can see how that point is fixed. And we're going to let this one remain free for now. And this is our ground. Make sure that doesn't do anything crazy. Likewise, we'll draw another line. Yep. And we're going to draw it from this point on our coupler, where it intersects this line and our coupler. And this is going to come back and touch this line. Yeah, that one. You see again, that's fixed, and this is free to move. So now, what we'll do now is we'll say, okay, we're looking pretty good there. Now to get this kind of out of our face, let's hide those lines. And now what we're really interested in, I guess we could have closed that up and get rid of those two, but we're interested in these three links. So now to create our mechanism, we're going to come in and say sketch, again on top of this sketch, on this plane, and we're just going to draw three lines. We're going to draw one, we're going to draw two, we're going to draw, we're going to draw, and we're just going to say this line and this line, we want to be equal in length. We're also going to say this line and our coupler, we want to be equal in length. Finally, this line and this line, we want to be equal in length. Now what we can do, because we know this point and this point, we want to be coincident. And I'll show you the reason why. Also, this point and this point will make merge. This point and that point will make coincident. And finally, we'll make these 2 points merge. Now, you can see what we've created is a device. Oh. Okay, I'm running out of video time. We'll record this one on the next.